So as I pick up your papers, I'd like you to start writing down some of the vocabulary for our single variable analysis lesson. Starting off with ones that you know: measures of central tendency, mean, median, and mode. Those are measures of central tendency because they are numbers that could be used to represent the center or typical value in the set. If Mr. Griffin wanted to know how students typically did on the first semester final, I could tell him the average, the mean was whatever it had come out to be, and that would be a typical score and would give him a good idea of what a typical student might have gotten on the final. If I had had one of you, which fortunately I didn't, but if one person had really done terribly and missed almost everything on it, maybe got a 30%, but everybody else was up around the A or B on the exam, that outlier would have pulled the average down. So maybe in that case I'd want to say the median score was 87 or whatever it was. Half of the students above 87 and half below. The median 87 would be another typical score that would give him a good idea of how students did. Or if it was on a quiz and almost everybody got 9 out of 10, I could say the mode was 9 out of 10. That was the most common typical score there. As you know, mean is the average, and we have two designations for the mean, and we are not going to make a big deal about the difference between these in this course. You will if you go on to take AP Stats next year or the year after. The Greek letter mu, it looks like a U with a longer tail on the left, is the mean of the entire population, the entire large group. So maybe I wanted to know the average income in the United States. Mu would mean I needed to find every single person in the United States and get them to fill out a survey and tell me how much money they earn, and then I could average all of those together. That's probably not going to happen. If I wanted to try to figure it out, I'd try to come up with maybe a representative sampling from all of the different states, rural areas, big cities, to have a good sample, but just of a smaller part of the population, and that would be X with a line over it, which we pronounce X bar. Median, as you know, is the middle number once you put the list in numerical order from smallest to biggest or biggest to smallest. And you also know that mode is the number that shows up the most often. The other stat that you have often found is range, which is the difference, the biggest one minus the smallest one. Range is not a measure of central tendency. If your scores on a test went from a lowest of 70 to a high of 100, what's the range? 30. Should I tell Mr. Griffin that the typical score was 30? That would not make sense. So range is not a number that's kind of the center of the data set. On to the new stuff. Deviation is going to be how far away something is from the mean. So I'm going to take your test score minus the mean. It's going to include a plus or minus sign. So if we had a test with an average of 89, so the mean is 89, if you got 92, your deviation would be 92 minus 89, 3. That positive means you were 3 above the mean. If you got an 85 on that test, 85 minus the mean 89 would be negative 4. That minus sign would mean you scored 4 below the mean. That's what it means by with the sign, the plus or minus. Question? The messiest one will be the variance, which we will label with an uppercase V. It is the average of the squares of the deviations. So we have to figure out the mean. We have to take every number in the list, take the first number minus the mean, square that. The second number minus the mean, square that. The third number minus the mean, square that. Add all of those up and divide it by how many we have, and that is what we call the variance. Once we have that, the standard deviation is relatively easy to find. All we have to do is to take the square root of the variance that we just found. Standard deviation is a way of measuring how spread out the data is. If I know that the average on a test is 85, but the standard deviation is only 1, that means most of you will have scored between 84 and 86. Over half of you will have been in there. But if the standard deviation is 5, then it's going to be more spread out. Over half of you will have been between 80 and 90 in that case. So that's where standard deviation comes into play. I'd like for you to add these two formulas for these last two things into your formula list just for easy reference. For the variance, you're going to take one number minus the mean, square that, plus the next number minus the mean, square that, plus the next number minus the mean, square that, till you're done, and then divide by the number in your entire set. And standard deviation, sigma, looks like an O with the bar just coming straight out to the right a little bit. This is a lowercase sigma. And the tail goes straight horizontally out to the right just a little ways. That will be the square root of what you just found with the variance. Some of these problems, we will be crunching this out, writing the steps out, maybe using the calculator to do some of the adding or dividing or squaring or square rooting. But we'll basically need to go through and show all of the steps for how we do it. Others will be much like when we did linear regression and you got to enter the whole list of data and then push the buttons and say, calculator, magically tell me what I'm looking for. There will be some problems we get to do that for to find the variance and the standard deviation and the mean. I'm going to do an example each way with you so that you can kind of see what the directions are and how you can tell when you're supposed to show the work of what's going on, what the calculator would be doing, or when you can just write down what the calculator says and let it do all of the work. Looks like most of you have finished writing this down. As soon as everybody has finished, we will go on. Our first example on the next page is going to ask us to find the standard deviation of the list. So let's think about what we're going to need to do. If we're going to want to find the standard deviation, we're going to want to get the square root of the variance. But to get the variance, we're going to need to take the numbers minus the means and do all of this to it. So the first thing we're going to need to do will be to find the mean for our list of data, right? So looks like everybody's finished writing now, so let's go on. But that, my dog's not in this list. She weighs, I don't know, 65 pounds or so. So we've got 4 pretty little dogs here, and we want to get the standard deviation. So as we just said, the first thing that we need to do is to find the mean. So it does not say use a graphing calculator on this. So you would write down your directions on your problem set. I'll probably just say find the standard deviation. So you will write down X bar for the mean is, and the calculator would be taking these and adding them up and then dividing by how many? 4. So you need to write down, that's the process. Now, depending on what the numbers are, once you've written them down like that, you might need to use the calculator to add them up, or you might be able to do it in mental math. I'm going to do this one mental math because the numbers are so easy. What's 4 plus 7? Plus 9? Plus 20? 40 divided by 4 is, so our mean is 10 pounds. If all your problem set says is find the standard deviation, you would probably then come down and your next step, you wouldn't need to write the formula, but this is the formula we're going to use. I have it here just so I can see it. You would write down V equals, so you're going to label what you're doing. And then you are going to get each of the deviations. You are going to say If my mean is 10, 4 minus 10 is how much? It is negative 6. And then I'm going to square that. My next number in the set was 7. So I take 7 minus the mean. What's that? Negative 3, and square that. And then I'm going to take 9 minus 10 is negative 1, and square that. And finally, 20 minus 10 is 10, and square that, and divide by 4. You need to write that down when it doesn't say use the graphing calculator, just like this. Then you may use the graphing calculator to punch that in if you want. Or you may do it by hand if the numbers are small enough and easy enough. So if you want to punch it on your calculator, fine. If you'd rather do it by hand, let's go ahead and figure out what this equals. $36.5, is that what you guys are getting? Those who are putting it on your calculator? Only if the problem specifically says find the deviations would you need to write down this step. 4 minus 10 is negative 6. 7 minus 10 is negative 3. 9 minus 10 is 1. 20 minus 10 is 10. On the problem sets, it'll be fine to do it like this. Yes, Hope? What? Thank you. Just thinking ahead to the next one. The only one that is positive is 20. That's the only one that was bigger than the mean in this particular example. Okay, we found the variance. What do we need to do to get the standard deviation? Square root of that. So store it and then the square root of it, or to the 1/2 to take the square root. On your problem sets, I'd like you to write sigma equals square root of v, so I know how you were doing it, what you had the calculator do. But then what is the number that the calculator gives you? Who's got it for me? I can't do square roots mental math. Emma? 6.442. Sounds good to me. Anybody with questions on that? Okay, let's change gears and let's start to talk about the normal distribution. You've seen plenty of data at different times, and not all data is a normal distribution. Your test scores, if you just change the numbers down here on this first graph so that 100 was the high, are closer to this. Most of your test scores are on the high end of the data. Most of your test scores are in the 80s and 90s, and very few lower than that. You would be very unhappy, and so would I, if our test data looked like this middle one. If most students got low scores and very few were getting high scores. Sometimes data is jumbled all over the place and we don't really even know what to call it. A normal distribution is going to be most of it is in the middle and symmetrically less and less as you go out to the sides. So if we drew the histogram in yellow, that would be approximately a normal distribution. The bell curve is one that is shaped like this, highest in the middle, and where it is the highest is going to be the mean for that data. So this next slide I do want you to jot down in your notes. So your bell curve never actually touches the number line. It's an asymptote, even though this looks like it touches there. The way that you're going to do these is you'll draw your nice straight line, use a straight edge if you can't draw straight enough by hand, and then you're going to draw your curve. You're going to draw one line, dotted or solid, straight down from the middle, and that's going to be your mean. Next, you're going to jump over to where the tail of the curve is getting close to the axis, and you're going to draw this line over here. And then symmetrically, you're going to draw one over here where it's also getting close to the x-axis. Then you're going to eyeball in between the mean and this line and divide it into thirds and draw these other two lines, either dotted or solid, on each half. Now, something cool about a normal distribution, the mean is right there in the middle. That was also the highest histogram bar, so that was also your mode. It was symmetric. Half of them were smaller than that, half of them were bigger than that. So the mean, median, and the mode are all the same if it is a normal distribution. There are some other special things about your normal distribution, but you may prefer to wait and write this down when I get to the next slide. We're going to then, we already said the center was the mean. The first line is whatever the mean is plus 1 times that standard deviation for that data. The next line is the mean plus 2 standard deviations, the mean plus 3 standard deviations. So if you go to the left, we're subtracting. Once you have done that, and I'll have this part again on the next slide, that means that 68% of your data is within 1% of the mean. So if I wanted to shade this much in, that would be 68% of all of the data would be in there. If I wanted to go to the second set of lines, 95% of the data would be within 2 standard deviations. 99% would be within 3 standard deviations. That means when I get out here, I've just got 0.5% in this little part out here, and another 0.5% over here to have 99% in between those lines. We do need to memorize these percents, 68, 95, and 99. You may find it easier to label it something like this. Since the graph is symmetric, if I have 68% within 1 standard deviation of the mean, that means that I have 34% in this little section and 34% in this little section. If I have 95% within 2 standard deviations, that means I have 47.5% between 2 standard deviations below and the mean. And same thing on the right-hand side. If I have 47.5% in these two pieces together, and I already had 34% in this one piece, that means this little section has 13.5% in it, and so on. So you kind of get what I'm doing. We'll get to problems where they might be asking, oh, how much is less than 2 standard deviations above the mean, going all the way forever? Or how much is between 1 standard deviation above and 3 standard deviations above? And so we'd want to be able to use these percents and these relationships like that, at least until we learn the easier ways, z-scores and all of that, when we revisit normal distributions in a future lesson. Everybody with me so far? Okay, so we have our percents memorized, 68, 95, 99. Okay, you will see problems in your problem sets that say the mean is, and tell how the data is distributed with respect to the mean. So you don't necessarily need to write down all of these words. Write down approximately normal. That means bell curve makes sense. Write down that the mean is 100 and the standard deviation is 5. Whenever you see problems like this, I'm trying to get it typed in on the problem sets, but I probably will have some that I miss. You need to also draw a bell curve. So what I want you to do is to draw a bell curve with a number line just barely below it. I'm keeping mine covered up for the moment. I'm going to go through those steps of how we do it. So you get your bell curve and number line drawn. Once you have that, you're going to draw one line from the peak down. And that's going to be your mean, so you're going to put 100 right under that. And I'll move the screen shade down in a minute, and you'll see where I have 100 on there. Then you're going to come over here where your curve's getting pretty close to the x-axis. And same thing on the left, draw those little lines. Then you're going to look and try to kind of eyeball it to divide this right half into thirds and the left half into thirds. So we've labeled the center with 100, and then we know the standard deviation is 5. So this next one needs to be 100 plus 5, or 105. Plus 5 more, 110, 115. Going to the left, we'll subtract and get 95, 90, and 85. So that's going to be part of what I want to see on these kinds of problems. Then we need to write those 3 sentences. What was the first memorized percent? So you will write to describe or tell how the data is distributed. 68% of the data is between, who can tell me what 2 numbers? Yes, Skylar? Except we'll go least to biggest. So we'll say between, so 1 standard deviation below and 1 standard deviation above, 95 and 105. What was our next percent that we need to memorize? So our next sentence is 95% of the data is between everybody, what and what? 90 and 110. Final percent, everybody? 99% of the data is between, everyone, 85 and 115. Does that make sense? Okay, these percents in the different sections is kind of like box and whiskers, which is what we're going to review next. Any questions before I go on to box and whiskers? So you've done box and whiskers quite a few times in the past, and you know that you find the minimum and the maximum, and you find the median of your data. So what percent of the data would be between the minimum and the median? If the median's the middle one, what percent's less than the median? Everybody, what? 50? What percent is between the median and the max? Another 50%. And then we get the first quartile by taking the median of all of these numbers in the bottom half. So what percent would be between the minimum and Q1? 25%. Same for Q1 to the median. Same for the median to Q3. And same for Q3 to the max. So what percent would be inside the box? What? 50%. 25 and 25 would be 50%. What percent would be from Q3 down to the minimum? And we could do other groupings to figure other things out if we wanted to. So similar kind of idea as the bell curve. If you choose to do graphs sometimes on the graphing calculator, if your minimum were an outlier, it's going to show that outlier as an X. And the whisker's only going to go as far as where it would stop if there were no outliers. I'm not going to expect you to be able to calculate this at any time, but the interquartile range is how long is the box? Q3 minus Q1. It is an outlier if it is more than 1.5 boxes bigger or smaller than the ends of the box. So for this one, let's see, if my box was this long, and then I'm going to move over here to my right, that same distance would come about here, and then another half a box would be about here. So if I had had a number over here somewhere, it would have been an outlier. Does that kind of make sense? Like I say, I'm not going to expect you to be calculating that, but I wanted you to know if and when you do these on your graphing calculators, that's what's going on with the x's. So are you ready to give this a try with graphing calculators? So we have a whole bunch of numbers, and if the problem says use a graphing calculator, this is going to be when you're going to get to just type the list of numbers in like we did with linear regression. If it doesn't say that, you have to show the steps by hand, even if you use the calculator to help with some of the arithmetic. So we need these things in red for the box and whiskers, right? Do we ever put mean or standard deviation on a box and whiskers? Does the box and whisker itself show you the mean and standard deviation? So we're going to do this one two ways. The first way will just give us the box and whisker, and it's probably not going to be what you will do on most of your problem sets. So what I need for you to do is to open up a new document, choose number 4, list and spreadsheet page. Look familiar, we've used that a lot with linear regression, but we're only going to do one column of data. I usually name it X up in that box A, and then as I enter the data, I'm going to put in those numbers 16, 22, 28, and so on. Raise your hand if that's not making sense, if you need me to show you something on that. I'm going to switch screens in a moment and get my calculator up here to show that. Once you have that in there, I need you to add a new page, data and stats, and it's going to be a scatter plot that makes no sense. You need to go down to the bottom and tell it to name the x-axis X, if that's what you named that top column when you did your data. And then you should have a bunch of dots along the bottom. So let me switch over to mine. Everybody have a bunch of dots down at the bottom? That looks like a dot plot, not a box plot, right? So what is your favorite button on these Inspires when you want to do something and you aren't quite sure what it's called or where to find it? Menu. And number 1 is plot type. We want to change. We don't want a dot plot. We want a box plot. And then choice number 2 is going to be box plot. And then you should be getting something that looks like this. Are we pretty much getting there? Look on with a friend if you're having a little bit of trouble. Now, this one would let me know the minimum if I move my cursor over the left end of the whisker. If I move to the left end of the box, it would tell me Q1 is 25, the median's 33.5, Q3 is 45, and the max is 61, but nowhere on there will it tell me mean and standard deviation. So most of the time, you are going to want to do these the second way. So I can get some of this out of the way. You want to now add a calculator page. And then we're going to go to our favorite button again, the menu button. And to the left of the number 6, do you see an X with a bar over it? That's kind of a clue. Oh, yeah, this is statistics. So you'll pick choice 6. And number 1 is stat calculations. We only have one variable. We just did one column, not two. So one variable stats. And then it says one list, yeah. And then pick the name that X that you named your data, and push enter. And should be seeing a list of a whole bunch of things. The bottom part of that list looks like what we just saw in the box and whisker. The min is 16, Q1's 25, and so on to the max is 61. If we go up higher in our list, let's see what we can find. We want to find the mean. Do you see something that looks promising for the mean? Which one do you think it is? Who can tell me? What was one of our new notations for the mean? X bar is 35.5, so we'd write that down in our problem set box. We also need to write down the standard deviation. And we've got a whole bunch of things here. It's not uppercase sigma x. It's not sigma x squared. It's not sx. You know the lowercase Greek sigma that looks like the O with a little tail out to the right? That's the one we need, so we're going to write down 13.730 for our standard deviation. Now let's go back, and you keep this calculator screen where you can see it for all of those numbers for my box and whisker plot. Because here are the steps that I need you to follow if you want a box and whisker plot. You don't just draw a box and some whiskers sticking out from it where everything's the same length. The first thing that you need to do is to draw a uniformly spaced number line. So your min was 16 and the max was 61, is that right? So your number line has to go from at least 16 to 61. I chose to go by fives because that was pretty easy. So I did 15 and then I went over 20, the same distance to 25, then to 30, 35, same distance each time until I got all the way out to 65. Then we are going to put dots in for the 5 critical values. So everybody, the min was 16, right? So up above the number line, I'm going to do a dot. I'm going to label it 16. I'm leaving enough space so I'll be able to draw my box when I get ready for that. What was Q1? 25. So then we do a dot on 25 and label that. What was the median? 33.5. So let's see, that's about right here. What's Q3? Just call it out. 45. And max was 61. Then we're going to draw the box and whiskers. I find it easiest if I draw my whiskers first. Be sure you are drawing the number line and the whiskers as straight lines. Use a straight edge if you can't freehand it decently. Then the box, so that the whisker comes from the center of the left and the center of the right sides, and then a line through that median. Does that make sense to everyone? Anybody with questions on that? Okay, our last one for today is going to be reviewing stem and leaf, and we are simply going to do number 11 from the new homework together as a way of reviewing and modeling what those need to look like. So number 11 asks us to draw this stem and leaf. So help me remember, what am I talking about when I say stems and leaves? I've got these 2-digit numbers, so what do I use for stems? The tens digit, and the leaves will be the ones digit. If you have, if it's extra, just hold on to it for now. If you have 3-digit numbers, if they are all spread out between 100 and 999, then your stems would probably be 1 through 9. But if all of those 3-digit numbers are 200 and something, it's not really going to do you any good to do one row, 2, and then all of those numbers in the same row. In that case, you'd probably want to do 2, 0, and on that row have everything between 200 and 209. The next row, 2, 1 for the stem, and everything between 210 and 219 in that row. Easiest way to do these, in my opinion, is to do them twice. One is some quick scratch work. So let's see, my smallest seems to be 3. Never skip. I don't know how far I need to go. I don't know if I need to go that far or not, but I'm going to start with 3. If I don't have any 40s in this list, I will still write 4, and I will leave an empty row on the right. And then I'll go down to the next row and do 5 and do the 50s. Then I just go through my list: 40, 55, 62, 31, 44, 57, 42, 69, 47, 53, 52, and 30. 2, 4, 6, 8, 10, 12. I just wrote 12 things in there. 2, 4, 6, 8, 10. There were 12 in my list. I probably didn't skip any. I don't really need to go past 6. Whatever my biggest one is, this one I'll stop. Then I need to recopy it. So my stems are fine. I know the order for those, but I need to rewrite it with the leaves in order. 30 comes before 31. And we're going to space these nice and neatly. Then we have 40, 42, that's going to go straight under the 1, and then 44, and then 47. It's not okay to write 52, 3, 5, 7 like that, where they're not lined up with the ones up above it. It's not okay to try to be doing it and, whoops, I missed one. I was trying to just look, let's see, all of my 50s. Let's see, I've got 52, and I see a 55 and a 57. Oops, I missed 53. I don't want to see it squeezed in like that. So this one should have been 2, 3, 5, 7, and the 60s are fine like that. Any questions on what we have covered today? So a little bit of time, just keep working on your own on the problems. The one thing that I do want to ask you to do, number 10 is one of the ones where I didn't get it typed in. I've changed it for next year. Number 10, add yourself a note, also draw the bell curve.